welcome everyone to the question and answer related to robotics and mining. Very exciting, topic, and really appreciate Norbert Jajan, who has been involved in all of these various projects in Europe. Who hopefully you've had a chance to watch the video of. Norbert, I don't know if you wanted to introduce yourself anymore, about a little bit about your background.
Not much. My background is from mineralogy and geology. So I'm from I'm coming from a strong geological background, but I was also always interested in the measurements and instrumental analytical techniques. So this is my background, and this is how I ended up with instrument development connected to robotics.
Cool. So we have a few questions. Early on in your slides, when you were doing the background, you showed that the rate of GDP, global GDP, is growing faster than the rate that raw materials are being extracted or produced. In that, I mean, they weren't on the same scale, but is this a matter, are we becoming more efficient in our use, or is this the impact of recycling or things like that?
Just a sec, I'm looking for that figure, and I think it's a bit of and this is the global raw material extraction, where you can see the different commodities like construction minerals, ores, and our GDP. This is not showing that GDP is quite a sum of everything, including these commodities. So I would not say we are not using them enough efficiently.
Okay.
I think we use and we try to recycle as much as possible.
Okay. No, thank you.
And actually, if you would like to compare to the today technologies, we are using much more efficient in both sides our commodities, both the projections. So, for example, if you mine an ore where is, for example, 1% of copper, you really few cases can take the full 1%. Usually you can take the only the one 2/3 of it, or 3/4 of it, or 90%, which is there. And the modern technologies are much more efficient, and also the usage, because earlier, if you use the mobile phones where you can find, for example, gold in the wires, it was 300 ppm, their gold content. Nowadays, the electronic contain only 30 ppm. So they use thinner wires with much efficient processing technologies. So I would say we are efficient.
Yeah. Okay.
Or at least try.
Good. So, what are you doing about the engineering of the various robots? Because they're working in mines and slurries, which can be really very corrosive environments. And so, is it a matter that any given machine is viewed as sort of deployed for a single project, and it's just going to be spent on that? Or is there some approach that you're doing to the engineering of the machines to tolerate these extreme environments?
It's quite a hard question. It's a mixture of it, because you have to, of course, when you develop a machine, something like the UNEX Wind robots, you develop for a certain environment, and as you mentioned, it's a mine environment, so we assume there will be, or there can be, acidity in the water. So by nature, from the beginning of the planning, we need to have these in mind and plan something which can tolerate the acidity. But there are a lot more site-specific requirements from the customer, because this is a robot. But we are not building a robot to have a robot. We are building a robot to able to collect the information, able to perform a certain job instead of us. And every job needs a bit tailor-made. The even the robot body or the propulsion or something unique or place a new instrument on board. So I would say the general frame it's a bit modular and has to have um, a general concept, but every case it looks like should be custom made.
Okay. That's
To have the best, of course.
So, looking across the different projects, is there coordination already in place between, say, Unexmin, with its site characterization, and then projects like Vamos and Robominers, which will really be about the development? Are they viewed as a continuum, or are they just really sort of doing things independently?
From outside, maybe it looks like an independent actions, but these whole research projects are quite coordinated by the European Union as how they selecting the different funds, and after that, it's an obligation, and not just an obligation. It's quite a straightforward and logic decision to do clustering with these projects. So instead of a single development, we used to meet and we are going to meet with these projects and have common meetings. We share the knowledge and look for overlaps and help each other and utilize each other's knowledge. For example, Vamos project started earlier, but in the Vamos robots have very similar navigation concept. The exact sonars are different what we use in Robominers, but certain structured light systems and the whole concept is quite the same. So there are connections with projects, even not just European Union projects, but other projects who are open for it. I can mention a project from UK, the PyBots, which are developing a robot for water pipeline inspection and sewage inspections. And we had this year, even this year, we had two joint meetings where we discussed our results. So I would say it's not a single one, but quite a building up and continuation. For example, you mentioned Vamos. Vamos was a really nice project, but from my side, as a mineralogist, geologist who's dealing with analytics, a very important part of Vamos was an onboard lip system which can work underwater and specify if they are mining if the slurry what they are mining is ore or waste rock. And that single lip system went forward with the Insight project, and they developing that particular lips, and we talking with each other. So I would say a lot of collaboration going on with these projects.
Excellent. Excellent. Invite anyone else in the audience. If you have a question, feel free to unmute and ask, or you can always type it in the Q&A. While we wait for that, there's another question for you, Norbert. What is the process that you're using in Unexmin and Robominers? Both seem to have an automated ability to analyze where the ore actually is, looking at the rock. So how are you doing that? How are those robots identifying the mineralogy? And what is the reliability? Have you run those tests in the field and have a sense for how accurate those processes are?
Um, They are using different equipments because when we started Unexmin, the robotic people were quite afraid of the navigation, and still one of the biggest challenge in navigating 3D because and without GPS, and because of this navigation and the very risky environment, and of course the expensive robot, we're talking about hundreds of thousands of euros, but it doesn't matter if it's euros or dollars, roughly the same. So 100, 300,000 euro on board. They were very afraid not to touch the walls. And also we went for National Heritage Site, UNESCO World Heritage Site, where we were not able to do any harm of the mine. And the first machine, we needed to have equipment which doesn't touch the wall, and the only methods were optical spectroscopy methods. So with the Unexmin, we use a kind of optical spectroscopy, a multispectral camera, which reaches the UV and also the close infra, which is able to reach in water, not a really big region. So actually, when they ask me how is the analytics underwater, I say it's much bigger challenge than do it in the moon or the Mars, because of the 1 meter of water or couple of centimeter of water you measure something. So the first was an optical spectrometer, and of course it needs to be extensively tested and adding new and new minerals. And also with the second generation we are working on now, it will be able to carry back a small amount of samples from the wall. And of course, when it's arriving back, in the laboratory we can measure it very precisely. Uh, with the other robot, the Robominers, it's a bit different because the Robominer can work in a slurry. So you more analyze it inside the robot from the mine slurry than the wall, but it's still a big discussion. And actually, for example, the mechanical concepts and many other basic concepts of the Robominer, it's still under design currently. So today, yesterday, and day before yesterday, there was a workshop about the main structures, and the mineralogy is still not decided. When we talk about spectroscopy, you and I mentioned it's difficult and really far from the optical region we can use for analytics. You don't have to think about something like a laboratory tool. So I'm not doing an optical spectrometer and asking what those mineral can be out of the 4,000, couple of 500 which is on the Earth, but we have standards from the location we want to investigate, and I already have those 15, 20 mineral spectra recorded, which needed to be fed back to the instrument. So it's a much site-specific design. This is how we can reach the accuracy. And of course, then a lot of points we need automated routines for the analysis.
Excellent. Cool. So, this is actually a question from me. I talk to a lot of students about future skills, things they need to do and learn. So as you're teaching your students at the university, what are you seeing as the kinds of skills and the background that they really need to engage, in projects like these and into the future, as this becomes more of a common application in geology? What's the kind of background you think students should be getting?
I think it's a good combination. If you have a good mixture of knowledge, I would say, because of course you need to have the basic knowledge in geology. You need to understand the minerals because you need to understand what you want to measure, and of course the physics background like the spectroscopy. And when I teach. Um, I focus on spectroscopy methods as a whole, and not just, for example, optical spectroscopy, because the electromagnetic spectrum, it's quite a continuous from radio waves to the gamma rays to the X-rays through the optical spectrum. And as you understand how an X-ray spectrometer works in an electron microscope, you will understand how an optical spectrometer works and so on. So you need to have the basic knowledge, both on the material side and also the physics side, and of course some computer knowledge, because these processing, the control of these sensors and data, how you process, for example, an X-ray diffraction analysis, it's with computers. So, I mean, the standard geological knowledge with an extra computer skills would be the base good start to start working on these projects. But you don't need to be a high-level academic to able to work on these projects. We have a lot of master students because we can select small things. For example, a robotic arm, just a 2 degree of freedom robotic arm, which can be a nice master thesis for a mechanical engineer student. So you start working on a robotic arm and will integrate your knowledge to the team. So
Yeah,
both the geologists and the robotic guys get closer to each other and will have a unique knowledge.
yeah, that's good. That's good. So again, opening questions. I don't know, Sharon, Leela, Joseph, any of you guys have questions for Norbert at this point? Sharon, did you have a question?
Well, I have a silly question. So I was interested in the Robominers and how they self-assemble underground, and then they can reconfigure, is the way I understood it. They reconfigure themselves into if as needed. So does that how far along is that at this point? Does that actually has that happened?
It's a very good question. How far we can take this self-assembly and reconfiguration of the robot. The main idea behind Robominers is when you establish a mine, a really huge construction cost is to dipping the shafts, dipping the vertical shafts, because creating the horizontal tunnels where you carrying the ore, it's not that costly. The really expensive is to having the big shafts, and with the concept to sending small robots for mining, we can reduce, if we reach what we aim for, which will be definitely not in 3-4 years till the end of the project, but it's a longer term vision to able to create a 30-40 centimeter diameter borehole where we can send down the units where they can join each other. And the self-assembly part can go quite well. In my talk, I don't know which slide is this, but when I showed Robominers, after the Robominers video, there are a couple of slides, and the last one, where I put all the Twitter and website availability of Robominers, there's a small robot picture on the right side. And that small robot picture is actually a prototype. During the submission, the Spanish guys created, and that is a square and four-legged robot. And actually, each leg of the robot is a single robot and able to move and detach and reattach itself or change their position. And end of the arm, there is a, a connector where different stuff can be added for that robot. So actually, if we talk about a laboratory proof and in small scale, not in the real environment, then even before the robots, the project started, we created robots which can self-assemble and reconfigure themselves. So this is where we are now. If we are able to do it in a slurry underground, not in the project lifetime, I think, but probably there must be experiments and not just experiments, but tests where two small robots or 2-3 robot can connect itself in a mud slurry pool. Probably it will happen in Tampere or in Finland or Tallinn in Estonia. These are the two places where we have the big slurry pools, or maybe in Germany, I don't know, but there will be tests, but not a 1-ton machine will. So it's nothing like a Transformers movie. Close to it, but not that close.
So what do you see, as these projects all move past sort of just the proof of concept, what do you see as the biggest challenge of getting these technologies used by industry, and hopefully globally?
What is the biggest challenge? I think the biggest challenge is how the mining industry can take these innovations or accept these innovations or using these methods, because that's quite a traditional business, and they have their strong codes. For example, if you'd like to take a deposit to the stock market, there are really written codes you have to pass. For example, how many drilling you need to able to prove you have those those reserves there, and to change it and place our technology and have an accepted place in this legally, it's quite difficult, I would say.
Okay, that's good. So one last round. Any other questions from the audience?
Yeah, so I had a question on the Vamos project. So through the video and through the lecture, I was just wondering how the ores were effectively like mined so that the company could like extract it. Because if the ores were mined underground, was the robot collecting the ores, or was it like going into the water and then it was collected through that?
It's the Vamos machine. It's I don't know the exact word, when you have this rotating head with the teeth, like a cutting head, like a cutting machine. And when you cut, you create a slurry, also sand grain size, but the bigger particles are a couple of centimeter. Actually, here the limit was 5 centimeter. So basically, the cutter had to cut below 5 centimeter, and what the cutting head was producing, there was a suction pump which sucked this slurry and transported this slurry to the surface and to the coast, to the lakeside. And the slurry was processed on the lakeside. So it's not just cutting on the water, but with an active sucking close to the cutting head. And actually, this slurry pumping was quite an effective way. And with the cutting, the problem is with the cutting, it's quite a good technology, but the really hard rocks are not that easy to cut because you need to have certain strengths to push the cutting head towards the wall, which you need a lot of weight. And hard materials, it's not the best technology, but soft materials and medium size, medium hard rocks were working quite okay.
Very good. Any other final questions? Hearing none, Norbert, I want to thank you again for doing a terrific lecture on the state of robotics and mining, and doing this Q&A. I think it's a it's a great opportunity. It certainly pushes innovation in geoscience, and that's a wonderful thing. So again, I'd like to thank you for all your effort on this, and look forward to seeing the progress on those projects.
It was my pleasure. You invited me here. And if you any further questions later, you can find me by my email. So you have my email. So please, if any following question arise, just send me, and I try to answer it with my best knowledge, and hopefully later I can show you even better advances in robotics, because I'm really curious. Our new robot, the UNEXUP now, will be ready in 1 month. So actually I could show only drawings, but 1 month from now we will have the real robot swimming, at least in the pool.